A very good morning to all my dear students. Welcome back to our session. Today I am going to teach you factorizing a polynomial. Factorizing a polynomial. So topics are factor theorem. What is a factor theorem? If p of x is a polynomial of degree greater than or equals to 1, x minus a is a factor of x if p of a is equals to 0. Next statement, its converse. If x minus a is a factor of polynomial p of x, then p of a is equals to 0. These two conditions exist. If p of x is a polynomial of degree n is greater than or equals to 1, degree of variable is greater than or equals to 1, then x minus a is a factor of p of x if p of a is equals to 0. First condition. Next one, if x minus a is a factor of polynomial, then p of a is equals to 0. Okay, this is the second one, is the converse statement of first one. Next one, next topic, how to factorize a quadratic polynomial. How to factorize a quadratic polynomial by using middle term splitting method. We should write middle term in the combination of two terms, right? Middle term in the combination of two terms. This is a quadratic polynomial. We have to factorize this polynomial by using middle term splitting method. Okay, next one. Divide a polynomial of degree 3 or greater than 3. So divide a polynomial of degree 3 or greater than 3 by a quadratic polynomial. In our previous classes, we already learnt about divide a polynomial by linear polynomial. So here, this is the divide a polynomial by quadratic polynomial. In the previous cases, degree of x is equals to 1. In this case, degree of x is equals to 2. Divide a polynomial by quadratic polynomial. Next one, factorize a cubic polynomial. Factorize a cubic polynomial by using middle terms. These both middle terms splitting method. Factorize a cubic polynomial. So these are the today our topics. Factorizing a polynomial. So first one is factor theorem. Next one, finding the roots of quadratic polynomial. Next one, divide degree of polynomial greater than or equals to 3 by a quadratic polynomial. Okay, fourth one, finding the roots of cubic polynomial. First one, factor theorem. Okay. So the factor theorem is, if p of x is a polynomial of degree n is greater than or equals to 1, then x minus a is a factor of p of x if p of a is equals to 0. If x minus a is a factor of polynomial p of x, then p of a is equals to 0. Let us take one example. This is example 12 based on factor theorem. Examine whether x plus 2 is a factor of x cube plus 2x square plus 3x plus 6. So this is a linear polynomial, right? This is a cubic polynomial. By using factor theorem, if x minus a is a factor of x, then p of a is equals to 0. So let's check first condition. So x plus 2 is equals to 0, x is equals to minus 2. Substitute x is equals to minus 2 instead of x in the cubic polynomial. So this is our p of x, right? P of x is equals to x cube plus 2x square plus 3x plus 6. P of minus 2 is equals to minus 2 whole cube plus 2 into minus 2 whole square plus 3 into minus 2 plus 6. So minus 2 whole cube means minus into minus plus, again minus, plus into minus minus. So minus 8 plus 2 into minus 2 whole square means 4. Plus into minus, minus 3 2s are 6, and again plus 6 constant term. So here minus 6 plus 6 both are cancelled. So that is equals to minus 8. 2 4s are 8. So that is equals to minus 8 plus 8. Result is 0. So here finally our result is P of A is equals to 0, right? P of A is equals to 0. So if x minus a is a factor of polynomial P of x, then P of a is equals to 0. So we can conclude that x minus a, here x plus 2 is a factor of given polynomial P of x. So x plus 2 is a factor of polynomial x cube plus 2x square plus 3x plus 6. This is the final result. So if x minus a is a factor of polynomial P of x, then P of a is equals to 0. Here our condition satisfied. Here P of a is equals to 0. So x plus 2 is a factor of given polynomial. Okay. So here our next topic is finding the roots of quadratic polynomial. Finding the roots of quadratic polynomial. Quadratic polynomial means highest degree of x is equals to 2, right? So let's do this first one. 6x square plus 19x plus 15. So 6x square plus 19x plus 15, right? So here split the middle term into two terms combination. So here 15 6 are here, x square coefficient is 6, constant term is 15. So here 15 6 are 90. So 90 factors are 9 and 10. So the sum of 9 and 10 is 90. It satisfies the middle term. Okay, it satisfied the middle term. So here 6x square plus 9x plus 10x plus 15. Okay, split the middle term into two terms combination. In this factorization method, we have to split the middle term into two terms combination. So here in this both terms 3x is common. In this both terms 5 is common. How? So 6x square means 2 into 3 into x, right? Here 9x means 3 into x. Here 10x means 5 into 2 into x. 15 means 5 into 3. Okay, in this both terms 3x is common. In this both 5 is common. So here 3x, remaining terms are 2x. Okay, plus here 3, here 5 is common, remaining terms are 2x plus 3. So entire 2x plus 3 is common. Here remaining 3x plus 5. So finally the factors of our quadratic equation 6x square plus 19x plus 15 is 2x plus 3 and 3x plus 5. This is the final result. Okay. Next topic, divide a polynomial of degree greater than or equals to 3 by a quadratic polynomial. Let's take example 16. Verify whether 2x power 4 minus 6x cube plus 3x square plus 3x minus 2 is divisible by x square minus 3x plus 2. How can you verify using factor theorem? How can you verify using factor theorem? So 2x power 4 minus 6x cube plus 3x square plus 3x minus 2. This is our polynomial p of x. Divide a polynomial. Here g of x is equals to x square minus 3x plus 2. So divide a polynomial p of x of degree 4 to x power 4 minus 3x cube plus 3x square plus 3x minus 2 by a quadratic polynomial x square minus 3x plus 2. So first we have to factorize this quadratic polynomial. Factorize this quadratic polynomial. So x square minus 3x plus 2. Okay, so here x square. Split the middle term into two terms combination. Here x square coefficient is 1, right? So here constant term is 2. X square coefficient is 1, right? So 2. We have to factorize the 2. So here 2 ones are 2. 2 plus 1 combination is 3. The sum of 2 plus 1 is 3. Okay. So here minus 2x minus 1x plus 2. So here x is common. So x minus 2. Here minus 1 is common. So minus into minus plus x minus into plus minus 2. So that is equals to, here entire x minus 2 is common. Remaining terms are x minus 1. Okay. So here x minus 2 is equals to 0 and x minus 1 is equals to 0. X is equals to 2, x is equals to 1. Substitute this x result in our polynomial p of x. So p of 2 is equals to, here 2 into 2 power 4 minus 6 into 2 power 3 plus 3 into 2 square plus 3 into 2 minus 2. So that is equals to, here 2 into 2 power 4 means 16 2s are 32 minus. Okay, so 2 cube means 8. 6 8s are 48 plus. So 2 2s are 4. 4 3s are 12 plus 3 2s are 6. Here minus 2 minus 2. So that is equals to, so minus 48 minus 2 means minus 50. So here 32 plus 12, 44 plus 6 is plus 50. So here plus 50 minus 50, both are cancelled, result is 0. So p of 2 is equals to 0. So here our first factor p of 2 is equals to 0. So first condition is satisfied. Let's check second one. So p of 1 is equals to, so 2 into 1 power 4 minus 6 into 1 power 3 plus 3 into 1 square plus 3 into 1 minus 2. So that is equals to 2 into 1, it is nothing but 2, minus 6 into 1, it is 6. So plus 3. So here is also plus 3 minus 2. Okay. So that is equals to, here minus 6 minus 2 means minus 8. So 3 plus 3, 6 plus 2 plus 8. Result is minus 8 plus 8. Result is 0. So here both conditions are satisfied. P of 2 is equals to 0. P of 1 is equals to 0. So by the factor theorem we can conclude that if x minus a is a factor of polynomial p of x, then p of a is equals to 0. If x minus a is a factor of p of x, if x minus a is a factor of p of x, then p of a is equals to 0. Here p of 2 is equals to 0. P of A means here P of 1 is equals to 0. So we can conclude that here x square minus 3x plus 2 is a factor of given polynomial 2x power 4 minus 6x cube plus 3x square plus 3x minus 2. So g of x is a factor of p of x. This is our final result. So by using factor theorem, if x minus a is a factor of p of x, then p of a is equals to 0. So here p of 2 is equals to 0. Our factors p of 1 is equals to 0. So finally we can conclude that g of x, here g of x is equals to x square minus 3x plus 2, right, is a factor of p of x. P of x means 2x power 4 minus 6x cube plus 3x square plus 3x minus 2. Okay, right. So next topic, fourth one, finding the roots of cubic polynomial by using middle term splitting method. So this is example 17. Factorize x cube minus 23x square plus 142x minus 120. Factorize x cube minus 23x square plus 142x minus 120. So here we have to split these two middle terms. Okay, so x cube minus 23x square, split 142x into two terms combination. So plus here minus 120, right, minus 120. So here is also the constant term is minus 120, right. So 142x means, so the summation of 120x and 22x plus 120x, you should maintain constant term and x coefficient should be same number. Okay, here 120, here is also 120. So next step is split this term into two terms combination. So x cube minus 23x means, so minus 120 plus 120x plus 22x. So 23x square means minus 22x square and minus x square. Here minus x square minus 22x square. Summation is 23x square, right? Minus 23x square. So here plus 142x. Split it into two terms combination. So here 120x plus 22x. Results gives us 142x, right? So here plus 22x plus 120x. Summation is 142x, right? So here we have to maintain constant term and x coefficient should be same. Here 120, here is also 120. And in the next step, so here 23x square, right? So here 22x. We should maintain x coefficient and x square coefficient should be the same. So here 22x, here is also 22x square. Here coefficient 22, 22 same. So here is also x cube coefficient, x square coefficient also 1, 1. Right? Yes. So here x square is common term. X square. So remaining x minus 1. So here 22 is common. Here 120 is the common term. Right? So here minus 22 x. Okay, so x, remaining terms are x minus 1. So here 120 is the common term, so plus 120. So x minus 1. So in the entire term x minus 1 is common, right? X minus 1 is common. So here x square minus 22x plus 120. This is a quadratic equation, right? This is a quadratic equation. So let us factorize this quadratic equation. So by using middle term splitting method. Okay. So x square minus 22x plus 120. We have to factorize this quadratic equation separately. So that is equals to, so 22x 120 means 120 into x square coefficient is 1, that is equals to 120. The factors are 12 tens are, so 12 plus 10 is equals to 22, right? 12 into 10 is equals to 120. So here minus 10x minus 12x minus 12x minus 10x is equals to 22x, right? So x square, instead of minus 22x we should write minus 12x minus 10x, minus 12x minus 10x plus 120, that is equals to, here x is common, x minus 12, here minus 10 is common, x minus 12. So x minus 12 is common, so remaining terms are x minus 10. Okay, here finally factors of a cubic polynomial is x minus 1, x minus 12, x minus 10. So factors are x minus 1, x minus 12, x minus 10. This is the final result. Okay, my dear students, hope you understand. So example 13 and example 14 and example 15, do this second one and third one from exercise 2.4 1 to 10th Roman. So these are all as your homework. If you have any doubts in this session, please contact my number. Thank you. Have a great day.